Welcome to Savoir Labs. I'm Jamie Goodyear. Are you a Java developer working on PPC64LE platforms? And are you using the Vector API? If so, this video's for you. Okay, we need to talk about the Vector API, specifically on PPC64LE. Just to bring everyone else up to speed on what we're talking about here, the JEP that brings in vector support to our JDK is still in incubator. It's actually gone through quite a few incubation periods. They were doing this to introduce an API that can allow us to do vector computations that were reliably going to be compiled at runtime and be able to do things optimally with our data. What does that really mean? Effectively, what we want to be able to do is have structures in our code that can do things simultaneously. What I have on the screen here is a very simple expression of this. Say we have an array of integers. In our case, we're going from 1 to 8, and we have a second array, also 1 to 8, and we want to do an addition to say, for position 1, add at position 1 of the other, and give me the sum. So 1 and 1 is 2, 2 and 2 is 4, etc., and so forth. In a regular way you would implement this, you would have something, it will iterate across the first array, adding into the particular position and putting into some additional result. So you would have 8 different instructions. It'd be first instructions, what's in position 1, then in position 2, etc., all the way through. If we use vectors, we can use something called SMID, which is the ability to do a single instruction on multiple data. And then you take those vectors and say, here's the operation I want to run. Here is register 1, register 2, output into register 3, my result, and do that in a single iteration. So you only have one CPU cycle gets burned. As you can imagine, this can be quite the performance improvement. Now, what does this have to do with PPC64LE? I mean, this is Java. Isn't it write code once and it runs everywhere just the same way? Not exactly. Let's take a look at a sample test harness that will exercise the vector support in Java. Okay, we're here in our IDE. A developer under the name of Tomer Zetzler, and I'm sorry if I pronounce your name wrong, published a testing harness to allow us to exercise the vector support in JDKs. I've taken this repo, and in the show notes below you'll find the link, and started running it on my PPC hardware. There are 5 different tests that he's put together, but it's really just 3. We have a sample of being able to do summation with vectors, doing complex expressions with vectors, and then doing a set that we're going to be doing conditional. So it's going to be trying to vectorize if-else statements. The simple sum test, what it's going to do is it's going to set up the same test in a array fashion, i.e. just using basic Java structures, and then implementing it the same way, but using vectors. We run this test 2 times. First time, we let Java compile, and the JIT, just-in-time interpretation of it, is going to produce the code, and we'll run that, and we'll take a look and see how long does it take the computation to occur. Then we run effectively the same piece of code, but with no superword. What that means is that we are saying to JIT, don't do your optimizations. We know better. Please just go ahead now and use the vector codes as we've instructed you to do it. We're going to do that for both the simple sum and for complex expression. Complex expression here means just instead of just summations, we're also doing multiplication, division, subtraction, a whole lot of mathematical operations. And we want to be able to see what is the performance when we're allowing the JIT to do its job, and then when we just say, hey, we're the developer, we want to use vectors, show us the performance with that. Finally, we're going to take a look at the array stat sample that was provided. This one's kind of unique in that what it's going to do is it's going to say, I want to go through various sizes of arrays and then count up the usage of when we have equalities, less than, greater than, and then we want to do the same thing, but we're going to use vectors to see, hey, what kind of performance do we get? Okay, let's take a look at some results. Before we begin going through the analysis of each one of these test runs, I just want to explain what you're seeing on the screen. This diagram is showing us the runtime of arrays and vectors in a normalized fashion. The number of nanoseconds it takes each operation to occur is quite a large range, so it would make the graph very difficult to read. So we normalized it to be able to show what the comparative runtimes are between the array implementation and the vector. In our case, arrays are in a light blue, and then we have in a dark blue the vector. On the bottom, you'll see the size of the arrays we're processing, 64 all the way up to a very large size. What we're trying to be able to show is the pressure on the system. So how much data is at the lowest level of the CPU, or when you have to go all the way up to, say, main memory to grab things. And then at the top, I just label say which particular algorithm are we testing out. In this case, our first one is the simple sum. So when we run this through, what we'll end up seeing is that the runtime is effectively the same for both arrays and vectors. Because this has been automatically vectorized under the hood by JIT, we expect to see similar runtime behavior. Now, what happens when we tell it to just go ahead and do vectors directly? All of a sudden, we see a change in behavior. When we are directly using vectors, we can see that there is actually going to be a sweet spot in how much additional performance we can get. This is when we're telling the CPU, hey, go directly to this particular set and use it. So we're seeing immediately in a very simple vectorization, in case it's just here summation, we can see a dramatic speed up. What about when we get into more complex code? In the most general basic sense, we can see that it's effectively always about the same, with a little tiny change at the smallest size of our array. But when we turn off the JIT's ability, all of a sudden we're seeing pure vector performance improvements. In this case, it's almost pretty uniformly just over twice as fast. This is really, really cool. So is the point of this video to tell you that, yeah, vectors, they're just really, really great. Start using them because look, all this performance is there in your CPU. Well, next we come up to the vectorization of if-else. What that really is meaning is trying to make branchless code. Why is that important? Okay, so down on the CPU, you've probably heard about branch prediction, and the CPUs will start speculatively executing things, going down one road and the other, and then picks them. And if it messes up, a whole lot of wasted instructions happen. But if your code is being effectively unrolled, so you can think of that as being, instead of trying to do like iteration, now you're just saying like, do this function again and again and again and again. It doesn't really have to choose, am I doing A, am I doing B? It just keeps doing all these executions, and it can go real, real fast. So in the harness that was provided for us, they initially tested this on a Intel system. I have in my lab a Xeon E2378, and I ran this test, and the results was that, yeah, you could, in theory, very much get some performance improvements with a branchless code by being able to vectorize these if-else's and finding out the qualities of these values, which looks amazing. Then I ran it on the PPC64LE system, and whoa, this is what we discovered. The regular standard implementation of arrays, yeah, that's our baseline, and all of a sudden now it is the performance, and quite more performant. This was on Java 17, so I decided I would try this on Java 21 to see if there was any improvements. No. Then I said, okay, well, let's try turning off superword and try to force it to just be the vectorized code, and same results. Okay, so this is a bit of a problem. What's going on here? Well, let's go take a look at the JEP documentation. I'm looking specifically at the specs on JEP 438 and JEP 448. Effectively, it's the same verbiage. What it comes down to is that the vector implementations have been brought towards x64 and ARM architectures. It does not prevent this from working well on other platforms such as PPC64LE, but it has not actually been implemented directly. So effectively, it's not that they're preventing this system from having performance. It's just that no one's actually implementing it and putting it in place. So what does this mean now for developers? Well, if you're building this yourself and you have your own application services and you have a part that you believe that vectors can help, great. You are now aware that if you're doing it for just some pure mathematical functions, implement it, try it out, and if it works for you, excellent. But if you're trying to do branchless code and trying to vectorize parts of that, you may want to check the results. Specifically, if you have to support on PPC64LE, you may want to be able to do this in just standard Java structures. Now, how else does this affect us? Well, if you're developing it, you obviously have a hand in knowing that it's in your application. Whatever you're downloading or have to port over some existing software, this is actually one of those cases where you discover this kind of problem and is using vectors under the hood, and all of a sudden things go real slow on PPC64. This is now allowing you to know if you're using that, you might want to take a look, see how it's being used. Hopefully you have the source code available and you can do some kind of re-implementation when they're on this platform. That being said, the specs have said that they hope implement it in such a way that you could possibly support this in the future. It's not been done in a way that prevents you. It just means that someone has to come in and provide that implementation. On that note, we're at that point in our video where we ask you to please like and subscribe and hit the notification bell so you'll get alerted about our latest content. Have a great day. Cheers.